Hi, my name is Dave Schultz, and I tutor stats and GRE and just a bunch of math stuff on Wyzant. Kelsey B asked a question. What does a test statistic in statistics actually measure? Which is a good question, which they don't really tell you enough about, and so that's why I'm here. What a test statistic measures is something called unusualness. Now, you can't imagine ever thinking, oh, I'm going to measure unusualness, and you probably never really occurred to you that it was something that could be measured. But if you're taking a stats class, it's something that you almost certainly have already been measuring. Now, how does one go about doing this? How does one measure unusualness? What does it even mean? Let's stop for a moment and look at something else. Length, which you know perfectly well how to measure. You can measure length in inches or centimeters or feet, and you can freely convert between them because they're really measuring the same thing. So 12 inches equals 1 foot, 2 feet equals 24 inches. You can convert easily between them, and you can imagine a table that does that. Oddly enough, unusualness can also be measured, and it can be measured just as distance can be measured in feet and inches and meters. Unusualness can be measured in 2 different units, which are just as easily convertible as feet and inches. So unusualness is measured in 2 things. One is probability. So you can think, oh, something that happens with a probability of 1 in a million, that's definitely unusual. So you can see something which happens with a probability of 0.9, that's not unusual at all. So that's a sense in which unusualness is plainly measured in probability. Now you might wonder, if it's unusual at 1 in a million and not unusual at some other value like 90%, then you can imagine that if very far apart is unusual and not very far apart is not unusual, there must be some point where you change your decision from unusual to no longer unusual. That is called the critical value. And so it can be done the critical value can exist in probability terms, and that critical value in probability terms is known as alpha. So let's get back to the original question, which is the test statistic. It turns out that we've seen that unusualness can be measured in probability. It can also be measured in a different measure, which is standard deviation. So something which is many standard deviations from the mean is unusual. Something which is not many standard deviations from the mean is not unusual. Those of you who've done t-tests and z-tests and all that, that'll be pretty obvious. And so if you think about it, as I said, you can freely convert between feet and inches. Well, when you measure unusualness, you can freely convert between standard deviations and probabilities because those are the 2 measures of our unusualness. Okay? A test statistic then is the standard deviation version of a measure of unusualness. So for example, if you get a test statistic of say 5.3, then you have 5.3 units of unusualness, where that is roughly equal to the number of standard deviations, but don't take that too far. Okay? The real way you turn unusualness measures the unusualness measure of your test statistic into something useful is you convert it to a probability. And the way you do that is with a z-table or a t-table or something like that. But let's look at a z-table for a moment. If you look at the parts of a z-table, along the left side and along the top is a z-value, which is literally a measure of standard deviation. A z of 1 means 1 standard deviation above the mean, just as a z of -2 means 2 standard deviations below the mean. And in the body of the z-table, those are numbers between 0 and 1, and those are probabilities. So for example, if you look on a z-table, a z of 1.0 is the equivalent of a probability of 0.8413, which is basically the same as converting 12 inches to a foot or a foot to 12 inches. You can convert probabilities to z-scores back and forth. It's a little more complicated on a t-test or a z-test or whatever, but basically a test statistic is a measure in standard deviation units of the unusualness of your data, which can then be converted to a probability, which is more useful. I hope this was helpful.